Hi there, I'm Alison Harper, a lecturer at University of Exeter Business School. This work was part of a larger project funded by HDR UK and in collaboration with University of Bristol and North Bristol NHS Trust. I was supported in the work package by my colleagues Tom Monks and Martin Pitt. In this talk, I'll describe the problem, what we did, the barriers and challenges, and the implications for our research and more widely. In terms of the problem, NHS elective waiting lists have been rising since at least 2010, and alongside lack of resources, inefficiencies in care, variable lengths of stay and delayed discharges have all been implicated. The effect of COVID has been to compound these challenges, and the problem for this work package became how best to evidence the most effective use of allocated central capital funds to increase surgical throughput through new capacity with the aim of meeting new NHS interim targets. To address the problem, an interactive model was required, which would be co-designed for use by managers and clinicians who didn't want to interact with model code or download or install software. So what they wanted was a user interface with sliders and buttons that they could experiment with the model themselves. The sorts of questions asked of the model were along the lines of how many theatres do we need? How many beds do we need? How can we maximise surgical throughput? What if we can reduce our lengths of stay in line with national benchmarks? What if fewer patients are delayed? What if we run evening theatre sessions or weekend theatre sessions or change the way we schedule surgeries across the week? I worked with staff to understand what inputs were required and the data available to support these, and also what outputs were needed, which were primarily surgical throughput and the balance of beds in theatres, given other model parameters. I used discrete event simulation, which models processes stochastically, and that means that it accounts for the variability and uncertainty that we see normally in healthcare processes rather than using means. It's intuitive for healthcare staff to understand as it simulates patient flow through a system, and changing the model parameters enables an understanding of how these changes may affect the real-world system. We also needed the model to address the questions that were material to North Bristol but wasn't overfitted to their problem, so that the model could be potentially applied more widely. So the question was how to make the model available and usable by our NHS stakeholders. I'm very interested in how to make models more useful in healthcare, and reusable models are one way of addressing this, as we tend to see similar problems in similar processes and application areas, and simulation models can be complex and time-consuming to build. Tom Monks and myself reviewed the healthcare simulation literature and found that from 2019 to 2022, only 8.3% of papers shared their model in some way. Of these, very few complied with simple open practices as recommended by the Turing Way, modelling and simulation recommendations, and the Open Modelling Framework, which meant that even where the model was shared, in many cases it couldn't actually be reused. So we developed this framework to support improving open practice in healthcare DES studies. We have a preprint and a conference paper demonstrating the applicability of the framework. It recommends using an open license, dependency management for package version control, at minimum a README file describing how to run the model, but ideally some enhanced documentation describing the model scope, assumptions and limitations, how to reparameterize or adapt the model for reuse, and how to cite the model. It should be findable in a code repository and archive to provide some guarantee of persistence, and a DOI for citations. Additionally, this project required a user interface and needed to be browser-based in a web app, and we also looked at other ways of sharing the model, such as hosted documentation using Jupyter Books and online deployment using BinderHub. Our literature review found few, maybe 2 papers that made their model accessible with a web app, and we've published a tutorial style paper here to support researchers to do so if they wish. Not all components are necessary for all projects, but we implemented all of this in this project partly to test their applicability. So the GitHub repo is here, Zenodo here. This is the link to the web app and to the Jupyter book, plus we have links to Binder, and Tom Monks has also created a Docker image so that the model can be deployed via Docker. This is the web app landing page. It contains some general information about the project and how to use the model aimed at the clinicians and managers who will be interacting with it. Over here, these 4 tabs on the left can be used to set up the simulation model before running it. The theatre schedule tab enables changes per day of week to the number of operating theatre sessions, how surgical types are scheduled across the week, and the numbers of theatres. And the schedule can then be generated and is then available to be used in the model. In the simulation tab, other parameters can be investigated, such as bed numbers, lengths of stay, and a scenario table can easily be set up to compare between different scenarios when the simulation is run. And obviously users can run the simulation as often as they like and output the results in the forms of plots and tables. In terms of challenges, time was the most significant, in particular when learning new techniques to implement the extra components, such as the web app. Other components, such as licensing and archiving the model, take no time at all once you know how to do it. Reuse concerns are often cited as a barrier, but enhanced documentation, clarifying the model's scope and limitations and how to modify the code, can address these. I was supported to implement the various components and set up the workflow from the start of the project, which reduced uncertainty and prevented unnecessary rework. So having a version of the framework and some quality worked examples available from the start massively reduced the knowledge barriers for me. It was a steep but valuable learning curve. The model is being used in Bristol to provide evidence to support the business case for Southmead Orthopaedic Facility, and it's also being modified and reused in another trust. So it has demonstrated a way of potentially reducing research duplication and increasing impact. We're also taking the open science work forward, and I showed you some of our papers, but we also have a grant application awaiting a panel decision, which has had some really great reviews. For other researchers, we have provided learning examples through the framework, through this application, and also worked examples from our papers, which can reduce knowledge and technical barriers to applying open practices, particularly for early career researchers and students of simulation. We haven't tested our framework outside of healthcare simulation, but it does align with existing guidelines, and we would welcome that. And finally, while not providing a pipeline for reproducibility, the framework supports efforts to improve reproducibility. I'd like to thank all listeners and the judging panel for this opportunity. I'd also like to once again acknowledge our funders and project collaborators, and also the support that I've received from colleagues, in particular Tom Monks, who has been instrumental to this work. If anybody is interested, the slides are available at the QR code, and I would welcome any questions. Thank you.